All right. My name is Hunter Line, and I also worked with Renee Doyle to make program 3 for CSCI 466. So the first part of this was to separate a packet into two packets as long as the message was at least 80 characters long. So right here in my simulation 1 and network 1, I send this really long data sample. And right here, it's just a simple if-else. If it's greater than 80, packet too big, splitting. Else, just send it. So here it is. Host sending packet too big, host sending first half, and other half ample. So pretty straightforward. The second part was to extend the network layer for packet fragmentation. So I'll just show the output really quick. So my test data for this part was this sentence right here. The fitness gram pacer test is a aerobic capacity test. Please be advised. And this is what the output looks like. So network is sending it. Oh, and something to keep in mind is I didn't carry over the over 80 characters for this part. I just thought it'd be more localized, so I just didn't worry about it. So that's in the first part, but not in the second or third part, because I didn't think that would be the point. So boom, host 1 sending packet. It got fragmented. You can see here you have your destination, your header information, destination right there. So now it's getting sent over the router, but the MTU is 30. Uh-oh. So you can see the header information has changed. The 1 is the MF for the flag, so there's more data coming. The offset is 0. Destination is still 2. So the MF is 0, so no more fragmented packets are coming. And the offset is 25. Destination is still 2. So for the second half, more or less the same story. 1, 0, 0, 0, 2. 0, 25, 0, 2. So cool. So now the packet's been fragmented and it's able to go over the link. So they're all going over the link. And here, the packets got reassembled. So, bam. Here's this. That got reassembled here. And this got reassembled here. So, looking at the actual code itself, since it's packet fragmentation happens in the router, I had to extend my router class. So my router class has a bunch of different stuff going on. I also had to extend the packet class, actually keep all the information. So the packet class also is looking at the MF and the fragment offset. So in my 2-byte, I had to change that to include my MF and my offset, and then from byte is the same story here. I had to change it to include my MF and my offset, and I also just gave my destination, my MF, and my frag offset limitations. So at max, the headers can be 5 bits. So here, and I'll just also add the header length because it's easier to keep track of it that way by adding them all up. So going down to my forward method of my router class, once I receive a packet, I create a empty list of packets. I grab my MTU, and then from there, I just have a while loop that constantly fragments my packet. So as long as the data is too big for the MTU, this while loop will continuously fragment the data. So each time it goes through the loop, that packet needs to have an MF of 1, and it also increases the offset. So once the while loop is done, whatever remaining data gets put into a packet, and the offset, by default, the packet will have a flag of 0, so no more flags will be coming. And then from there, I have a for loop that forwards every packet. And then going back up to my UDT receive, I have a while loop that checks to see if the fragmented packet is 1, and if it is, I know that there's more packets to come, so I just keep on letting packets come through. And if the packet's 0, I recognize that, oh hey, no more packets are coming, don't gotta worry about it anymore, delete it. So that's how UDT receive works. So for the last part, I had to create this topology, or this network, and then I had to create 2 separate paths. So from host 1, it go from host 1, A, B, D, host 3, and then from host 2, it would go host 2, A, C, D, host 4. So it's easier to visualize that by going step by step. So simulation 3, network 3. So for the first one, I'm going to have host 4 send it. So host 4 should go to, oh sorry, it's sending to host 4. Client 2 sending to host 4. Boom. Clear. And as you see here, I had to extend the simulation time. Host 4 goes to A, goes to C, goes to D, goes to host 4. So that works. That's going through the bottom layer. And another thing to keep in mind is, for the most part, this code right here is the same as in your network 2. It's just that it should never activate because I set all my MTUs to 100. Because the point of this one was just using the routing tables. I didn't think MTU would matter. So that's showing that it gets sent to host 4. So now I gotta show that it gets sent to host 3. Oh god, I hate that so much, it's so annoying. Boop. Host 1 to router A to B, B to D, D to host 3. So that shows the other path is working. And if I do both, they send the same message. It's just a lot to read through. But it's just the combined versions of these two. So looking at the code itself, I just used a lot of thread appending, link layer adding, made a bunch of routers, and that created the network. And what I used for the routing table was a dictionary. So the key is the interface, and the value is what interface goes down. So like 0, 1, 0, 1. And then for router B and C, it's only going out one way, so I just gave it one key value pair. So that's how that works on this router table area. For the network, when I'm forwarding it, I figure out what my out interface is going to be by grabbing it from the table, and then the for loop just checks to see, oh hey, oh yeah, it's the right out interface, we better use that, and then it gets sent over. Okay. So that's how that works. And that is everything. I did not do the bonus point, so don't have to worry about that. But that's how my program works. I'll be including a compressed file containing all of my work, along with my partner's text file. Thank you for your time, man.